my name is Fahmid Al Rifat. Today I will discuss cross-site scripting attack and demonstrate this attack-related seed slap problem. A cross-site scripting attack injects malicious code into vulnerable web applications. This attack does not target the application directly. Instead, this attack targets the user of the web applications. A successful cross-site scripting attack can cause reputational damage and loss of the customer trust. Depending on the scope of the attack, here are common examples. A successful attack can replace session cookie, which allows cybercriminal to impersonate real user and use their account. Cross-site scripting is when an attacker manipulates a vulnerable website so it returns malicious script to the user. Typically involves JavaScript, but an attacker can use any client-side language. Cross-site scripting primarily targets JavaScript due to the language integration with many browsers. This attack can be exploited weakness in different programming languages. There are many methods, like targeting website function that accept user input, malicious code on the other domain, stealing session data, and so on. Let's consider the above scenario. In the first step, the attacker discovers a website having vulnerability that enables script injection. They inject the website with malicious script and steal visitor sessions cookie. When the user visits the website, the malicious script activated. In the final step, the visitor session cookie is sent to the attacker and attacker can do whatever he wants. Here, user triggers the execution automatically when he loads the page or hover over the certain page element or click the hyperlink. The attacker can carry out XSS attack directly. For example, in the email message containing a malicious link. Certain XSS attack don't have a particular target. Either the attacker exploits a vulnerability in a site or application targeting random victims. So we can understand the impact of this attack can be very dangerous. Static content can be changed, sensitive data can be stealed, and user privilege can be gained. Let's see the above XSS attack example. In the above example, attacker insert a vulnerable script in the database server. Client wants from data, the script run and pop-up happens. This process will repeat for every client. Let's talk about some defense mechanism. Nowadays, there are some dynamical tools to against this attack. Though they are often limited and produce a high ratio of false positives. I forgot to talk about cross-site scripting attack types. First type is non-persistent attack. A non-persistent attack, also called reflected attack, is a type of cross-site scripting attack that takes place when the web application returns a response that contains some of or all attack vectors. The main point is the vulnerable application essentially reflects the injected script but doesn't store it. Second type is persistent attack. A persistent attack is also called stored attack. In this type, a cross-site attack that occurs when the malicious code is permanently stored on the server of the vulnerable web application. Last type of cross-scripting attack is DOM element-based attack. Sorry for not adding them in slides. These are the seedless topics. Now set the lab environment. To set lab environment, we have to copy the seed server in our local server. After DNA configuration, we have to build our container with container builds command. We give dcup and dcbuild command to compose and run that container. We clear our SQL server. Let's proceed further. L web application is a social media web application. These are the username and password for the website. In the preparation step, we have to check our HTTP live header. Is it working well? Task 1 is to posting a malicious message displaying an alert window. Let's copy this and logging as Sammy, who is an attacker. Sammy went to his profile and go to edit profile. Let's clear his previous profile, and after clearing it, in brief description we copy the malicious code, script code. In the alert field, we write our desired message which we want it to pop up. That function will show the message as a pop window. Let's save the script. Our attack already started to run. Let's go to victim account. Here our victim is Alice. When Alice will visit the Sammy's account, Alice will fetch the attack. Here we can see that Alice can see you have been hacked by Sammy. This is how our first task is done. We can do this attack without writing JavaScript code directly. We can host this JavaScript file in local machine and give the HTML link in the description box. This will be same as before, so I will not demonstrate it. Besides, instead of hosting in local machine, we can also host in www.example.com. Our task 2 is posting a malicious message to display the victim cookies. This is like task 1, just we have to change the alert box message. Instead of writing some string, we will write a JavaScript variable which is document.cookies, and after running this attack we can see the cookies of Sammy. Let's log in from Ali's account who is victim, and when Ali's go to Sammy's account, Ali's cookies are shown here, which is different from Sammy's cookies. Let's clear and proceed to our next task. One important point, we don't steal the cookies from here. In the task 3, we will do the quick stealing. In this task, when victim visit malicious server, his or her cookie will pass to attacker. Here, attacker will use netcat to listen the cookies. First of all, we have to write a JavaScript code. Inside JavaScript code, Sam can use image tag. Yes, Sam have to do a trick. He have to give the netcat listening port number in the source of image tag. So when a visitor visit this malicious site, his cookie will go to the netcat listening port 5555. Let's open the netcat as a runner. The netcat is listening. Setup already started to run. This is the Sammy's cookies, but we need to get a victim cookie. So let's log in as a victim ID. Alice is here victim. When Alice visits Sammy's profile, her cookies also shown here. This is Alice cookies. As this attack ran 2 times, and same Alice cookies is duplicated. Let's clear the code for next attack. Now further proceed to our next task. In this task, when a visitor visit attacker website, he will be attacker friend. This is a JavaScript code to construct a GET request. Construct a GET request, we need to find the proper HTTP format. Let's open the HTTP like as we did in Corsair attack. We have to give the URL in the send URL field. Here Sammy is the attacker. Sammy have to know how the add friend HTTP request work. To know this, Sammy have to open HTTP live before adding any friend. Let's assume Sammy wanted to be Ali's friend and open HTTP header and open the request. In the request, we can see that it is a GET request. We copy the URL and paste it in our JavaScript malicious code. Let's open our JavaScript malicious code. Here ls GUID is 56. We have to change this to Sammy's GUID because we wanted to make someone Sammy's friend, not Ali's friend. Let's do this and find Sammy's GUID. One more important thing, we have to concat token after send URL, because in HTTPS header we see the token are concatenated after the URL. Let's find Sammy's GUID. Is 59, so we fixed friend equal 59 and then attach our token. This token prevent cross-site forgery attack but don't prevent the cross-site scripting attack. This is our JavaScript code and it automatically send request when victim visitor visit the attacker site. Now we copy the JavaScript code and paste it in about me section. In About Me, there are two types of mode. One is editor mode, one is HTML edit mode. On HTML edit mode, we comment out the paragraph text. After commenting out, and we save it. Now we will log in as allies to see the attack work successfully or not. Allies have no friend when ally visits Sammy's profile and Sammy become or his friend. Now similarly perform this attack for Bobby. Bingo, Bobby also becomes Sammy's friend. Now we'll answer the two questions. First question is explain the purpose of 1 and 2. 1 and 2 long line is used for token generation which prevent cross-site scripting. Second question is if we switch to text mode in About Me, will the attack successfully work? Let's check. We will copy the malicious code as before and paste it in About Me field, but this time we will paste in text format. Here we copy the code and paste it as text format and save it. We can see the code is visible here. Let's inspect the source code. This is because bracket part of the script is converted to Unicode, and so the JavaScript is treated as text, not a script file, and attack will not successful. Now logging as allies with victim, and similarly we visit Sammy's profile and see allies friend. There is no friend and Sammy is not added. So the question answer is no. Now let's move on our fifth task. In this task we have to modify victim profile with the cross-site scripting. Before that we use get request. In here we have to play with post request. Let's copy our JavaScript code to send our post request. When visitor visit that attack page, this script will automatically run and send a post request with proper format. We have to construct a format. To construct a format, let's check the format first. We need Sammy's GUID here in this parallel post. We inspect the Sammy's profile to get Sammy's GUID. We will get Sammy's GUID in the end of the source code. Now in the GUID field, we will paste the Sammy's GUID, which is 59. Sammy do not want to attack him on, so he give extra if else condition. Now we have to find the URL. To find the URL, we have to open our HTTP header live. Now we write Sammy is my hero, and before clicking save, we open our HTTP live, and let's see the format of our post request. In the post request, we need a URL. Let's copy the C server URL here, and we can see in the below here we need first token. So in the content part, we first concat token, then we need TS here, and the TS part in the post request. So we have to give same way in the JavaScript file. After that we need some more additional field like username. Here the username, so we have to give serially. After giving user name field, we have also to give brief description field and concat in DS field in JavaScript variable. We are not done yet. We also have to concat GUID because post request has GUID. This GUID is Sammy's, but if we wanted to change victim bio, we have to give victim's GUID. Sammy wanted to attack allies or other, so he don't know the allies or others GUID. Instead of hard coding GUID, Sammy use JavaScript variable and paste the whole code in the HTML editor mode and save it. Now we'll perform our attack. Now we logging as Alice. In Alice profile, she have no bio. When he visits Sammy's account, JavaScript code run and his bio is Sammy is my hero. Let's check for Bobby. Bobby has no bio. When he visits Sammy's profile, his bio also changed to my hero. Sammy is my hero. Question 3 is why we need this if-else line. This is because attacker do not wanted to be attacked by his own JavaScript code. Let's check. Sammy didn't affected by his own malicious code. Thanks for having patience. Bye bye.